Hey guys, welcome to December 11th, 2021, and this is a Green Engineers update. I was super excited to talk about this new update, but I kept forgetting to do it um, before before I went to sleep that night. Today I did remember to do so, and so I'm super excited to talk about some new cool updates. So, number one, the workshop, the shop is taking place. My place of business is coming together. The place that I will be hosting machines and then building machines that will manufacture my products. So the four main products that I'm talking about is hot end, the hot end that I invented, the shredder called the Reclaimer, the Filament Maker version 2, and my 3D printer, right, design. And then also for my three services, which is my online classes that I teach and engineering and things like that. And then uh, 3D printing, commercial 3D printing, and also filament making. So I have a couple updates on a couple of those. So one, the shop is progressing. Um, it's looking a little tight for that 6 months, but I think for sure I'll be getting all three services up within those 6 months, and then should be able to run the a couple of machines, maybe not full 100% till the end of the year, but I plan again the end of 2022 being full 100% ready to manufacture, if not manufacturing a couple products already, maybe not all of them, but a couple products already. So in the meantime, when those pieces of equipment come up, I will be, testing some things here and there because a lot of those machines can be run autonomously by themselves. So I could be doing more build out of the shop while that particular machine that's up and running is running. And then I mentioned that I got my first mill. So I have a Tormach 1100 with a Series 3. So it's the older series. And it has the 10-piece tool changer. It has the fourth axis. It has the fixture plate. It has the smart cool. It has the touch screen. It has the load sensor. It has tool setter. It used to have an enclosure, but I took the enclosure off. I'm going to build a new one for the shop, a new and better one, more ergonomic. So that guy will be used to manufacture the screws, the feed screws, compression screws for the filament maker version 2, and also any sort of other custom metal components that need to be metal and that won't be made on the water jet. And then the water jet is something else also I plan on making. Currently, no update on the water jet. Um, it is sitting in the queue. It's one of my top two machines. So the three machines that I want up is a printer, which I have printers up, and I'm going to talk about that in a second with the printers because some things are shifting around there. Some crazy things are happening there. And then the Tormach, right? The mill. And then the Tormach also, I'm going to get a rapid turn, which is basically a lathe attachment to turn, which is basically like a horizontal spindle attachment. So you could turn your mill into a lathe. So it can be a lathe, a fourth axis, and a mill, right? At the same time. The only thing that the Tormach does not have fifth axis capability. Anyways, so the mill slash lathe, right? So mill slash lathe, 3D printer, and then water jet are my three main ones. And then my fourth one would probably be a laser cutter. Probably not a fiber laser cutter. Probably not like 1,000. I was looking at like 1,000 watt fiber laser cutter, but probably just a CO2 high wattage, 150 watts laser cutter. Probably 150 watts, and then I may have like a lower power laser in that same laser cutter for like a lower power etching or engraving, right? So what we're still seeing with that, because I'm going to talk about something here in a second about my 3D printer that was originally um, going to be part of that, but may have to change now because of some design changes. So I may not even need the laser at all. And then, like I said, I have also a couple other printers. I'm waiting on a Sonic. I have a Sonic Mega 8K that did come in. I've been struggling to get good prints on it, so I can't necessarily recommend it yet. I designed a heater for it because it's been 65 Fahrenheit, so like 20, like under 20 C. It's been like 16 to 18 C, and most resins are anywhere between 20 and 30 C. So I built a heater for that. So I may release that heater design. The heater design is pretty good, but I want to make it a little bit safer before I release something like that. So if you guys have the Sonic Mega 8K, you can be using that. The Sonic Mega 8K is a 3D printer by Frozen. It's an extremely large MSLA printer with an 8K basically laptop screen, 15-inch laptop screen in it. It's a very, very high resolution. And then also I have the Sonic Mini 8K coming in as well. Probably next year at some point. It's supposed to be this month or next year. This month, December or January, but we'll see. Because last time Frozen took a really long time. They were like 3 months or something behind schedule. Something like that from when I was originally supposed to get it. Anyways, so those printers will also be there. So pretty much all my printers will be up. But each of those from the resin, it really stinks. So even with, I even tried with soy-based resin because that vat holds 1.5 liters. The smell is absolutely atrocious, especially when it's curing. So that will have to be inside some sort of fume box or something like that. Fume box / heated box as well to heat the whole thing. I'll probably just have a heater on the inside and then insulate the box. And so I just have a heater inside the Sonic Mega, and then also maybe some things that I could put around the outside, some seals to seal the thing up. Anyways, so those printers will be in there, and then the Tormach with rapid turn, and then the next thing would be the water jet. And then when I have the Tormach, then I could easily make parts for the water jet, especially how the Tormach has the 18-inch travel on the X, which would be pretty good. Again, the bed of my water jet, I plan to be 24 by 24. So we'll see how that goes. I might have to get some of those parts made elsewhere, but I need a place to store it and do some testing, which I'm out of space at my current location. So that's the whole idea with the shop. Anyways, so the next big development is the 3D printer. The 3D printer I'm working on. Last week, I came up with a new. Actually, it was last week or this week. It might have even been this week. This week, I think it was last week. Last week, I came up with a new way of kind of 3D printing. This new printer has various different technologies that I've come up with that may or may not work into the final design. One of them was the hot end that I decided to break it out into its own product entirely. But I came up with this new way of 3D printing in general. It's like I don't really want to go too much further into it at this current point, but I have that, and I have different ways of movement and the hot end, right? Like I said, and some of those different things are going to be never seen before on printers, right? On 3D printers. So super, super, super excited, but it may not use the laser anymore. We'll have to see. The laser for manufacturing it. So it may not need the laser anymore. Eh, well, we'll see. We'll see. I may use it for cutting plastics, certain plastics. So it's one of the fastest ways of doing it, and keeps you from really scratching the plastics with the water jet, because you got splash with the grit, and you could scratch the plastic because it's going to be transparent plastic. All right, then talking about the filament making service, I was able to get my first successful size usable filament of the polycarb ABS mix. Reason being was that I was not getting enough dice well, so I was able to get a couple more nozzles from this competing company that I'm messing around with their extruder right now, and I was able to drill that out slightly. by 0.2 millimeters. And then now I'm getting the right dice well to where it's pretty consistent. But what I'm getting is a bump up and down, right? So it's getting like some random jumps sometimes, and it will go like really low. It'll go like 0.2 millimeters low. So it'll go like 1.55, and then I'll have another one will hit like 1.95 or even 2 millimeters. And so what I'm thinking that is that is the variability of the size of the pellets that are going in there, because it's basically just regrind, which is most likely what you would be using with my shredder is regrind, right? So what I'm going to be doing this weekend is I plan on printing a sieve, which is basically got quarter by quarter holes in it, because my shredder is quarter by quarter. So anything that does not go through those quarter by quarter holes, right? And a sieve, I don't know if you've seen a sieve before, but basically it just is a mesh, right? And the mesh is a certain size of X by Y, right? In this case, it's quarter inch by quarter inch. And if that is used to make sure that the particles that you have that go through it are that size or smaller, which is perfect what I need for this machine, right? And the reason why I pick quarter by quarter is that my shredder is quarter inch blade width, and it actually turns out that one of the dimensions, the width of the cut, is set by the thickness of the blade. And so when I've cut stuff with my shredder, it's been almost exactly quarter inch, like plus or minus 5 thousandths. So very, very exact, right? But it could be a strip, right? So if you put in a big flat plate, it'll cut a quarter inch strip out of it, but the strip will be longer. So you'd want to go back in and cut that strip again. Now, one of the things with the sieve is it may not prevent that from happening, where it will fall weird and not fall through the hole. So the best thing to have is you have multiple layers of that quarter. And then if it gets stuck, then you know that one of those dimensions is too big, and you should try to shred it a couple times, right? Send it to the shredder. But every time you send it to the shredder, it may not land in the right position that you want, and then you have to shred it again. So basically anything that does not go through the sieve, that's just a regular 3D printed sieve, it doesn't need to be super exact, should be able to be cut down with the shredder, right? And then that way I'll have a more consistent thickness. Now, if you notice, when you buy the pellets that have never been formed before, they are very consistent length, right? So the length is pretty consistent. I actually have I actually took some data on that. It's underneath this screen here. On a notepad where I took 20 pieces, I mixed it all up, and I took 20 pieces and I measured them. They're very, very consistent. Usually the average is about eighth inch long. And what you'll notice is it looks like wire cut up. And so that's the next thing that I'm going to talk about. It looks like it was filament, but cut up. So that might be another thing that I have to investigate, but we'll see how well this does with just making sure that there's no big pieces. Because what I think is happening in those is either it's jamming up and then there's like a void, and then there's no pressure buildup because the stock has kind of jammed up because a piece that's too big got stuck in there. Or, well, most likely that's what I'm thinking. Or it's just like you have a patch where it's just a whole bunch of thin material where it's not properly mixed very well, right? So, because this stuff is like powder all the way up to large chunks, up to about almost slightly above quarter by slightly above a quarter pieces. So it's very variable, which is something that you would get if you were just getting industrial waste. You could be getting something like that, so you have to be able to print with that. So I'm gonna try the sieve. Worst comes to worst, I will probably look into doing this other option, which is something that I kind of saw at Protopasta, which is they have a mixing machine that at the time when I went there, which was a long time ago, that was about 6 years ago, in their Washington facility, is they have a mixing machine. So they have two different types of machines. One that's very good at mixing, but not very good at keeping constant diameter, and one that's very, very good at making constant diameter. And so what they would do is they would use the mixing machine to put iron ferrite or whatever they use to make a PLA Mostly they do PLA, but to make a PLA magnetic, right? They do put in iron something uh, to make it magnetic, or make it conductive, or make it glow in the dark, or make it carbon fiber, or to make it the coffee filament. So they would use that machine first to mix the raw material with the pieces that go in, right, with the other stock, with the additives, right? And then they would blend that together, and then they would extrude it, but they wouldn't really care much about the diameter. The diameter does not have to be perfect to your extrusion diameter. They would just try to get it extruded as quickly as possible. And then it would go through a chopper, and a blade would come down past a shear and cut the material to length, to these consistent lengths. And the funny thing is that it looks exactly very similar to what you have with the pellets. So I'm wondering if in industry, instead of extruding it, well, they extrude it still, but they put it through a press instead of a continuous extrusion screw. They put it in a press it out, and then chop it down. I might have to look into how they actually make the stock material online or whatever, but it looks exactly like filament chopped, right? You could actually see some of the shear lines on it, on how it's been deformed from when a chopping blade came down and cut it. So if that doesn't work with the sieve, I might have to look into creating some sort of chopping system, and then have to integrate that with the final product of my filament maker version 2. Is that either you have to have some sort of sieve. You probably still will want to have a sieve just in case something went wrong and one of these pieces is too big, right? And it's going to jam up your the version 2, right? It's going to jam up the extruder. So either I'm going to have a chopping mechanism that will, you extrude it once quickly and then chop it up, and then it could be variable size. The size doesn't really matter, and then you re-extrude it again, or you have to sieve it very, very well and then shred it back down. But you're still probably going to have to sieve it, right? Because otherwise it'll jam up and then you can't extrude it the first time. So hopefully it's just that first step, the sieving, instead of just the sieving and then extruding and then chopping and then putting it back and extruding it a second time. Because what that would mean is that your productivity would cut down in half, right? You'd have to extrude it twice to get it once. To get one good roll of filament, you would have to extrude that filament twice, right? But for somebody that's doing um, like small batches of filament here and there, that's not that bad. Of recycled filament, that's not that bad. But if you want to test a piece of equipment and run it through multiple rolls of filament and getting it into people's hands to try it, now that's difficult to do, right? So that's well, it's slower because you have to print it twice. You have to make the filament twice. And then, so for the printer, I have brought back, because in my new shop, I'm probably not going to be bringing the Stratasys Dimension 1200 with me, the ES SST, Soluble Support Technology 1200 ES Stratasys, manufactured in 2008. I will probably not be bringing that with me, right? So that will either be sold or donated, most likely, because I'm going to start developing different pieces of equipment, and it has three bad things going for it. Uh, the software is super outdated. The prints are decent, but the software is super outdated, so the prints now are better. It's really heavy, so I guess four things. Really heavy. It's very, very loud. The fans in it are extremely loud, and it takes up a lot of space and uses a lot of power, right? So those are the five bad things about it that really bring down the efficiency or the usefulness of the printer. So what I have done is I've went back and I've retrieved my backup printer, the Tronxy X5 SA, that I've done some conversions on. I put a micro Swiss on it. I got a Titan extruder from Tronxy on it. I have I put on a silent stepper board, Tronxy's silent stepper board on it. So the loudest thing on it now are the fans. I just today installed a Creality tent around it, the heating tent with the aluminum foil on the inside. And then I took the heater from my resin printer, which is currently out of commission right now because I need to find a place where the smell doesn't, disturb the shop that I'm currently in. So in the second shop, if it's inside of a a box that I could degas it outside, it would be fine, right? So that's the plan with that. So I stole the heater from that. I ordered a higher temp heater. The heater I'm using currently for the resin printer is a 250 watt because it's a very large printer. And I upgraded the one on the Tronxy to a 500 watt with like a thermostat. And so what happens is that over time, as it heats up, the thermostat will actually increase the resistance and cause it to pull less power, right? So it'll slowly lower the power. So for example, my 250 watt one, it has kind of the same deal. It's from the same manufacturer. It'll start out at like 300 watts and then decrease all the way down to like 190 watts when it heats up. So this will do the same thing. It'll probably be like 500 watts down to about 300 watts um, when it heats up, and then hopefully get me around somewhere between the 40 and 60 C range, um, and pull about the same amount of power as the Stratasys. And then it slowly will start to morph. And that Tronxy X5SA is a standard X5SA, not the 400. So it's a 330 by 330 by 330, I think, millimeter build volume, which is like 13 by 13 by 13. And that guy will slowly morph into a test stand to test this new technology that I came up about a week ago. And I've been currently testing its feasibility, and it seems that it is possible. Some of the hiccups that I've looked at, as far as the parts, the actual equipment to have on each unit to get that to work. The parts, it seems that the crucial parts, seems that that is viable. And I looked at some simulations, and those seem also viable. And I did some calculations, and those also seem viable. Now the test is that would that actually happen in real life, and what type of value versus cost equation are we looking at, right? So is it going to make sense cost wise? And so working on that, and then that's going to be the printer that's going to go with me to the new shop as it's morphed, as it's being changed. And then the Stratasys will either be sold, donated, or something like that, right? Or given away, whatever. So that's my current update. The new technology I came up with, changing from the Stratasys to the Tronxy. The findings with the extruder, that you need to sieve the material first, and that you may need to extrude it, cut it to a more consistent size, and then re-extrude it again to get decent size without these massive variables, these sudden spikes of 0.2 millimeters for like a minute, right? But with that, I mean, 95% of the material is good size, but then you'll have that spike, right? And that'll cause a jam and cause some material damage. I have not printed with the material yet. I may print with the material this weekend and actually use that material to print the sieve as the first test with the Tronxy. And the main reason why I went back to the Tronxy is that right now I came up with that technology. That's number one. Number two is my Stratasys is actually down right now. The toggle bar is stuck. So I would need to have to take apart the head in order to fix it. And so I decided that I was going to check out my Tronxy again, which I haven't used in a year plus, a little bit, maybe a year and a half or more. And so I tried it, and it's doing great prints. I'm doing prints for work, and then also prints for the printing service with it right now. But I have it down. My printing service I have currently turned off for more evaluations of the Tronxy before I continue. And also, I technically have to verify the Tronxy to the web service. I mainly brought it in right now on the web service to finish the jobs that my Stratasys could not complete because it was down. Anyways, so new printing technology, Tronxy printer, Stratasys not coming with me, the shop update, those the Tormach, and these other and the water jet and the printers going into that, and then the timeline looking still good, and also with the extrusion sieving or having to cut the material down and try to re-extrude again to get good filament. All right, I think that's pretty much it for this update. Hopefully I talk to you guys next year probably. So if you don't hear from me again, happy holidays, happy Christmas, happy New Year. And I will see you guys next year in about, 20 days. All right, guys. Thanks for watching, and I'll see you guys in the next one.